Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 245. Please turn to it. Page number 245, and today is our lesson number 360. These problems that you see there on page number 245 are the exact same problems that appeared in the first edition of the revised GRE. We have already solved every single math problem from this book. If you're interested in watching the original solution, you will find the original solution on day number 154. Today we're just going to redo it at a little bit of a faster pace. If you feel that you're confused about something, or if you need in-depth help, you can watch day 154, and in addition to day 154, the concept that we're going to deal with in this problem is what is known as factorization. If you need help with the concept of factorization, if you're not very good at it, I am at a list here, the videos that you can watch to get some more practice on factorization. Day number 338, 345, 349, 312, 313, 314 and 315, 142, 141, 123, 124, and finally day number 99, 100, 101, 102 and 103. There are plenty of videos there, there's plenty of material there for you to get some practice. Factorization is what we'll have to do in this problem. Here's what's going on. We are given an equation of the parabola. The equation of the parabola is given as follows. We are told that y equals x squared minus 4x minus 12. And we are being asked to find the x and y intercept, x and y intercept, and the coordinates of the vertex. Now standard parabola, as you know, a standard parabola can sit anywhere like this, and the x-intercept would be the place where the parabola cuts the x-axis, which is why it's called the x-intercept. It cuts the x-axis here, and it cuts the x-axis here. And we need to find we have to find the coordinates of these 2 points. For finding the x-coordinate is very simple. The x-coordinate of this point, or rather the y-coordinate here, is 0. We do not know what the x-coordinate is here, but the y-coordinate is 0. Because it cuts the x-axis, the place where the graph cuts the x-axis, the y-coordinate is 0. Similarly here, we do not know what the x-coordinate is, but we know the y is 0. Since y is equal to 0 here, the y-coordinate is 0 here, that's exactly what we're going to do here. We're going to set it equal to 0, and we're going to solve this quadratic equation, and we're going to find the corresponding x-coordinate, which is called the roots of this quadratic equation. We're going to set it equal to 0 because y is equal to 0. And at these 2 points, y is equal to 0. So that's our quadratic equation. And we just have to factorize it, that's all. We just have to factorize it. So here we go. X squared minus 4x minus 12 is equal to 0. And we're looking for we're looking for 2 numbers such that when we multiply them, we get negative 12. We're looking for 2 numbers such that when we multiply them, we get negative 12. Their product has to be negative 12, and their sum has to be negative 4. Their sum has to equal negative 4. Can you think of 2 such numbers? Can you think of 2 numbers such that when we multiply them, we get a negative 12, but when we add them, we get a negative 4? Pause the video if you have to for a couple of seconds. Put your thinking cap on and see if you can think of 2 such numbers. I'll give you a couple of seconds, okay? The 2 numbers that we need are negative 6 and a positive 4. Negative 6 times positive 4 times positive 2 rather, not positive 4. Negative 6 times positive 2 is going to give us negative 12. And similarly, negative 6 plus a positive 2 is going to give us negative 4. Those are our factors. So we have to break up this negative 4x into those two parts. I'm explaining too much here. I didn't want to do that. I don't want to explain this. This is not a video about factorization. We just want to solve this parabola here. Factorization is right here. So here we go. Remember, -6 and a +2. X squared can be written as -6x plus a +2 minus a 12 equals 0. You see, -6 and a +2 is going to give us this part right here in the middle. Now what is common between these two terms? The common factor between these two terms, x squared and a -6x, is x. And that gives us x minus 6, because x times x is going to give us x squared, and x times -6 is going to give us our -6x. Now we look at these two terms. Do you find anything common between 2x and a -12? The common factor between 2 and -12 is 2. Once we take out the 2, what are we left with from this term here? We are left with x. And what are we left from here? We are left with -6. Again, you see 2 times x is going to give us 2x, and +2 times -6 is going to give us -12. And this has to equal to 0. Now we find that in the first term here, this is the common factor here. X minus 6 is common. We take it out, and we are left with x from here, and a +2 from here. Again, you see, x minus 6 times x minus 6 times x is going to give us this part, x times x minus 6, and x minus 6 times 2 is going to give us this part, 2 times x minus 6, and this has to equal to 0. Now the only way the product of two quantities can be 0 is when one of those two quantities is 0 or they are both 0. So either x plus x minus 6 is equal to 0 or x plus 2 is equal to 0. Or of course they are both equal to 0. If x minus 6 is equal to 0, this implies that x must be +6. On the other hand, if it turns out that x plus 2 is equal to 0, that implies that x must be -2. There we go. We found our two intercepts. The parabola cuts the x-axis when x is equal to -2 and +6. We need the room to plot the parabola. I have no room on the blackboard, so let's plot it here. Okay, I'm going to erase all of this thing now. We don't need it. So here we go, 2, 4, 6, and 2. The parabola goes through these 2 points. These are the x-intercepts. These are the x-intercepts. There are 2 more things that are left for us to find. One is the y-intercept right here, the place where it cuts the y-axis, and the next thing we have to figure out is the vertex right here. Let's first talk about the y-intercept. The y-intercept is where x is equal to 0. At this place here, the x-coordinate is 0. So this one we already know that x is +6 and a -2. So the coordinate of this one is -2 and a and a 0 and a +6 and 0. Similarly here, the y coordinate is going to be 0. The y coordinate, we don't know what this is, the y coordinate is 0. If the y coordinate is 0, at this point the x coordinate is 0. At this point the x coordinate is 0. The place where the graph cuts the y-axis, x coordinate is 0. If x coordinate is 0, all we have to do is substitute 0 in here and we can figure out the value of y. We know y equals x squared minus 4x minus 12. All we have to do in order to find this y coordinate here, just plug in x equal to 0 here. If x is equal to 0, we get 0 squared times 4 times 0 times 12, which is just -12. Y is equal to -12. The last thing we have to figure out are the coordinates of this guy, the vertex. Let's do it, shall we? But before we can find the location of vertex, we first have to find what is known as the line of symmetry. The line of symmetry, of course, is so called because the two sides on either side on that line are symmetrical. That's why it's called line of symmetry. It's like a mirror. It's right here. That's our line of symmetry. Everything that we see on the left hand side of that line is symmetrical to everything on the right hand side. The line of symmetry. The question is, can we figure out what is the equation of this line of symmetry? Well, the equation of this line of symmetry is very straightforward. Why? Because this is -2 and that's a +6. From -6, from -2 to +6 is 8 units. And since it's symmetric, the line of symmetry, where two sides are symmetric, the line of symmetric is going to sit exactly halfway through. Exactly halfway through. This is 8 points. It's going to sit 4 points from either end, from this end or that point. It's going to sit 4 points. So that's exactly what this is here. Right here is the 4 points here. Right here. From here to here is 4, and from here to here is 4. And this is your line of symmetry. And the equation of this line of symmetry is x is equal to +2. Why? Because +2 is exactly 4 units from -2, and +2 is exactly 4 units from +6. That's your line of symmetry. So we already know the x-coordinate of this point. X-coordinate of this point is 2, because it's on the line of symmetry. The vertex is the lowest point on the graph. The lowest point of the graph is where the line of symmetry cuts it, hence making it into two identical halves. So the x-coordinate is 2. The question is, what's the y-coordinate of that point? It's also very straightforward. We have the equation here. We have the equation. We know y is equal to x squared minus 4x minus 12. Y is equal to x squared minus 4x minus 12. X is 2 over here. If x at that point is 2, all we have to do is put in the value of 2 for x in here, and we can figure out the value of y. That's all. So y has to equal 2 squared minus 4 times 2 minus 12. 2 squared is 4, 4 times 2 is 8, so it's -8 and a -12. -8 and a -12 is going to give us -20, -20 and a +4 is going to give us -16. So this y coordinate here is -16. And there you go. That's our parabola. That is our parabola. It does not look very symmetric, but it has to be exactly symmetrical along the line of symmetry. This is called x equal to 2. This is our line of symmetry. Line of symmetry. That was all. Let's take care of the very last problem that we see on the page, which deals with a circle. It's a straightforward problem. It's a very simple problem. Let's take care of it here, shall we? So that we can get it out of the way and this page is all done. Okay, just give me 1 second. Let's deal with circles. Number 20. Problem number 20, we are given an equation of the circle. We are told that x minus 1 squared plus y plus 1 squared has to equal 20. Now we know from our videos on day number 125, 126 and 127 125, 126 and 127, and if you haven't watched these 3 videos, you make sure you watch those videos, because that's where you're going to learn the derivation of the equation of the circle. Don't memorize the bloody thing. Don't memorize the equation. The equation goes something like this: x minus a x minus a squared plus y minus b squared equals r squared. But like I said, don't memorize it. If you watch those three videos, you will have an intuitive understanding of it, and that will help you a great deal in terms of grasping what it is all about and why, and you will understand why the center of this circle, even though it says x minus a and y minus b, center of this circle is actually positive a and positive b. The radius is root of r. R squared is your radius. Radius is r, it's the root of r squared is what I was talking about. Radius is r. That's all. So how do we write this thing? This is already x minus a, so our a is just 1 right here. But this one is not written as y minus 1. It has to be written as y minus a quantity. This one is written as y plus some quantity. So how do we write this as y minus some quantity? Well, that's very simple. This has to be written as y minus a negative 1. Y minus a negative 1. So RB, so this y plus 1 whole squared has to be written like this. Y minus a negative 1 whole squared equals, what was it, 20? Equals 20. So RB is actually negative 1 and RA is positive 1. So the center here is going to be, A is positive 1 and RB, as you can see, is negative 1 right there. That's your center. The next thing they ask us is the radius. Well, the radius, this is r squared. The radius is going to be the square root of 20. That's all. This is r squared. R squared is equal to 20, therefore r is going to be root of 20. The last thing they ask us is the area of the circle. Well, the area of the circle is simply pi r squared. Pi r squared. R squared we know is 20. So it's pi times 20 or 25. The area of the circle is 20 pi. That's it, we're done. Tomorrow we'll begin the next page. I'll see you then, okay? Bye now.